students, here we are again. Yes, again, learning more about nuclear energy. And so this week, to recap, we've learned about nuclear fission. We learned a little bit about nuclear fusion. We learned about some problems with nuclear fission. And we learned a little bit about how nuclear power plants operate. And so today, what I'd like to do is to finish up our notes and learn a little bit more about how we actually can detect radioactivity and use radiation for our benefit. Some things that maybe you haven't even considered. So let's begin with our notes here with detecting radioactivity. There's a really simple device, and I'll show it to you in person in the lab, and it's called an electroscope. You can actually make a homemade electroscope and utilize it to measure the presence of some forms of radioactivity. You can even utilize it to measure some static electricity or the flow of electrons from your own hair, especially in the wintertime when static electricity is a little bit easier to be transmitted. And basically, in making a homemade one, if you have a flask or a jar of some kind and put a stopper in the top with a hole, the metal rod coming down through it, and on the top, you could even use a piece of aluminum foil rolled up into a ball. And on the bottom of the rod, here's the most important part, is having, and it says here, leaves of metal foil. You can use aluminum foil, really, really thin, and drape it over, a little strip, draped over a metal wire that has been bent perpendicular to the rod coming down from the center. And you want to do it in such a way that the leaves of metal foil are almost touching one another, hanging straight down. Because here's how an electroscope actually works. If you charge it with charged particles, whether it is static electricity from your hair by combing your hair or rubbing a balloon on your hair. Of course, some of you might have better luck at doing this than me, if you know what I mean, and no making mean comments about me, by the way, all right? But, or if you have radioactive particles, which you know are also charged particles, the bottom line here is this. If you've got particles that are all charged with a single charge, whether they be all negative or all positive, you touch them on the rod at the top or the ball of metal, the top of the electroscope, you may remember about ionic bonds and how opposites attract one another. The opposite of that is true as well. If opposites attract, then what do like charges do? They repel one another. So if you charge this device, this electroscope, with all the same charge, let's say we're talking about static electricity here for a moment, they're all negative electrons. Those negative charges travel down, charge the two sides of the metal leaves, and because opposites attract, then like repels, since both sides of that foil will have the same charge, they'll repel one another. It's kind of like two similar sides of a magnet getting close to one another. Pooh! They're forced in opposite directions. So this is a really simple way of detecting radioactivity, is just using a homemade electroscope. I mean, they do have more technical, better constructed electroscopes professionally, but you could make one yourself. And I'll show you one in the lab. All right, another device that we also saw last week, although ours was a more primitive example of this one, is a Geiger counter. A Geiger counter, it's named after the German scientist Geiger who invented them, but a Geiger counter basically does the same thing as an electroscope, but it translates that information into either audio clicks coming out of a speaker or the moving of a dial, whether it's an analog or digital readout. It gives a more quantitative, a more measurable quantity of radioactivity that is being measured. So a Geiger counter is can be a lot more useful than just an electroscope. An electroscope can tell you, oh, there's radiation present, but it really gives you no idea of how much. A Geiger counter can tell you a little bit more information. Geiger counters are like standard equipment in nuclear power plants, in addition to other things too. But you really need to be able to quantify or measure the amount of radioactivity in order for people to be safe. All right, there's another one called a cloud chamber. Cloud chambers can measure alpha and beta particles. They can also measure cosmic radiation from space. You actually can make a homemade cloud chamber as well, believe it or not. It's a relatively simple device, can be a simple device. And let me just show you the diagram here. Okay, here we have a jar, and it is filled with nothing other than alcohol vapor. Alcohol vapor, vaporized alcohol. Alcohol, as you may know, has a much lower boiling point than water does, and it vaporizes very readily at room temperature. That's why you can wipe a table down with an alcohol wipe, and before you know it, it's already dry because that alcohol has evaporated. Now, if you put that alcohol in a closed jar, basically a container, and allow it to vaporize, it forms a vapor within that jar. Now, if underneath that jar you place some dry ice, which you can get from like meat packaging, Omaha steaks, you buy some good yummy steaks from Nebraska, and it's usually packed in dry ice. Put dry ice underneath that, and what it does is it lowers the temperature, obviously, of that alcohol so that it actually begins to condense and forms what is called a cloud. Now, that alcohol cloud that is then contained in that jar is susceptible to small radioactive particles or cosmic particles traveling right through the gas. And when they do so, they actually interfere with the cloud appearance, and you can actually see particles zooming through the cloud chamber. So, cloud chamber, another example of a way that radioactivity can be detected. Here's a fourth way. Fourth way is using something called a bubble chamber. Bubble chamber is rather similar to the cloud chamber in that it uses a similar concept and approach, but it's pressurized in such a way that it is more effective, and it usually utilizes higher tech recording equipment, the camera, in order to detect and record the movement of these radioactive particles that are zooming through the device. So it's a little bit more high tech. So we've got electroscope, Geiger counter, cloud chamber, bubble chamber, all ways of detecting radioactivity. But what I'd like to end with here today are ways that humans have utilized radioactivity. Oftentimes, as you know, we hear the word radioactivity, and automatically we get a negative image in our mind of bad things like the China syndrome, melting holes through our entire planet. But we currently utilize radioactivity for positive things. Here are some examples of those things. Number one, diagnosing diseases. We can be very thankful for the positron emission tomography scans. otherwise known as PET scans. Has nothing to do with cats and dogs you may have at home, but it has to do with the emission of radioactive particles. Positrons. The positron emission tomography scan is a wonderful diagnosing device that enables doctors to diagnose diseases like cancer and to pinpoint locations in order for other devices or techniques to help them cure patients. For instance, one cancer therapy that is growing in popularity, especially for cancers in hard to reach places like the brain, is something called the gamma knife. Now, as you can imagine, the gamma refers to the gamma radiation that it emits, and the knife isn't a physical knife, but it is a concentration of the flow of gamma rays into a very precise and limited and controlled direction and location. So let's say you've got some type of a brain tumor, some cancerous growth inside your head. The surgeon may not want to open up your head in order to remove that cancerous growth because they might kill you in the process. But rather, now we have this gamma knife technology that can be a concentrated and directed beam of radiation that can go right through the skull, right through the healthy tissue, and be focused like you would take a magnifying lens and focus the rays of light. It can focus the gamma radiation on just the cancerous cells and poof them out of existence. So it's a wonderful new device, still being developed, but gives great hope, and it utilizes radiation for helpful things, not harmful things. Now, another thing that we have utilized radioactivity for is for dating objects. Now, this doesn't necessarily help us live longer, but it can indicate the how long something has lived in the past. Dating objects, it can be used to measure, and it does measure the beta decay of various things, including like the carbon 14 isotope in organic material, and can be used to date things up to thousands of years old. We can fairly accurately, because it's within that historical time frame, we've been able to utilize this technology in order to determine the almost precise age of objects that have been covered or recovered or uncovered. Archaeologists love this type of technology. Anthropologists love this type of technology because it helps them date and confirm things from historic and prehistoric times, again, utilizing radioactivity. We learned more about that in the last topic when we talked about half-life, if you recall. All right, so one more way that we can utilize radioactivity for our good is that we can use it to actually detect radioactivity. If you have microwaves at home, especially an older microwave, it may not be a bad idea to purchase a quick little kit, a little detecto kit from a home goods store of some type, and it uses radioactivity in there in order to detect leaks from your microwave or even your cell phone for that matter, because there are a growing number of devices that you have in your own home that emit radioactivity. And when they get older, it's a good idea to test those appliances or devices to make sure that they're not leaking more radioactivity into the environment and you, in order to get rid of them when they get old and get a new one with newer technology. So not a bad idea to detect leaks. So again, another positive thing that we utilize radioactivity to keep us healthy, keep us safe, and to keep tabs of our past so that we can have a better future. All right, now, what are some of the potential dangers of radioactivity? Well, number one, they cause disease. They can cause diseases. There are different modes of exposure to radioactivity. You can have external exposure, which is to say the radioactivity is you're being exposed to it on the outside of your body. There's also internal exposure. You could inhale radioactive gases. You could ingest radioactive contaminated food. And those forms of radiation can get into your body and can affect you from the inside as well as from the outside. And there are various forms of radioactive exposure that we as humans sometimes have the potential to be exposed to. And if we're exposed to too much radiation, not only can it cause disease, it can also cause death. And folks that are really prone to potential death from radiation poisoning are those that work in nuclear facilities, first and foremost, and especially nuclear facilities that have experienced accidents or problems, and they have to go in and try and clean them up. They have to be very careful about being exposed to high levels of radiation. The videos I showed you the other day of those nuclear accidents gives you an example of that type of exposure. But here's the deal. You know, we often think that radiation exposure is only due to human made sources like nuclear power plants or microwaves or what have you. But check out this following graph. Check it out. The vast majority of radiation that we're actually exposed to on a regular basis are from natural sources. The vast, sorry about that. I moved the sun and the earth. Woo! Let me get out of there. Okay. The vast majority, if this were a graph, well, this is a graph. I don't have numbers on it. I'm just trying to give you an example here. The next one will show you some numbers. But look at the little pie wedge on this graph. These are human sources of radiation. All the rest are natural sources of radiation from the earth itself, from the sun, from the universe, bombarding us with radiation. Only a fairly relatively small percentage of the radiation we're exposed to comes from human sources. Here's a better breakdown with actual numbers. Check this out. In the region of the country we live, in northwestern New Jersey, we are exposed to a lot of radiation, potentially, because we live on a geologic formation known as the Redding Prong. The Redding Prong is a geologic formation which contains a lot of uranium rocks. And because of the radioactive decay of uranium, it results in a radioactive gas called radon. Radon. If you've ever moved, ever bought or sold a house, especially in this state, then you know your house has to be tested for radon gas. It is estimated that it is the second largest source of death due to lung cancer, next only or second only to cigarette smoking. So radon is invisible, odorless, tasteless, and it could be in your home right now. If you've got a basement, it's undoubtedly in your basement. Some folks even have high concentrations in their water. But in the state of New Jersey, it's required by law to have your homes tested for radon when you move, especially. And some of you may even Be aware of radon remediation systems that you have in your homes in order to exhaust those gases, those radioactive gases, out of your house, so that you don't die of lung cancer without even realizing it. But check it out. Radon is a natural source of radiation. More than half of the radiation you are exposed to in your life is from radon gas. There's also about 11% that's naturally contained within your body. Yes, there are parts of your body that are mildly radioactive. Just for being alive, you're somewhat radioactive. Rocks and soil, radiation in some rocks and soil, cosmic rays from space. All of these areas, this purple and these other colors here, all of these are natural sources of radiation. There's not much you can do about it. You're exposed to them and you don't even realize it. We don't generate these forms of radiation. We can take steps to remediate them, like the radon remediation systems in homes, but they are naturally existing. It's only this wedge over here that I showed you before that are man-made sources of radiation. And most of that is due to the medical field. Medical X-rays, form of radiation. That's why when you go to the dentist, you wear that lead vest when getting X-rays, and the X-ray technician leaves the room to minimize the amount of radiation they are exposing themselves to. Nuclear medicine, again, in the medical field, sometimes nuclear medicine is required in order to kill things like cancer to increase your lifespan and your health. Some consumer products, and you may remember from the last topic, smoke detectors. Smoke detectors in your own home have a certain amount of americium 241, a radioactive isotope that can save your life. So it's not necessarily a bad thing. And less than 1% from other sources. But again, these little pieces of the pie are man-made sources, human sources. The rest of them, the vast majority of radiation that we are exposed to in our lives, is from nature itself. So the more you learn about radiation and nuclear energy, hey, it can clear your mind of some unnecessary fears and concerns and can educate you to make our future a better future for everyone. And so, with that lovely positive thought on your minds now, I'm going to call it quits and say bye bye.